Hi, folks. Welcome to Math 141, Pre-Calculus. So this is the very first section of our summer, and it is section 1.1 from our textbook called Functions and Function Notation. So we're going to jump right into it and take a look at this first idea, something called relations and functions. Okay, so we're going to start off with this question: what is a relation? All right. And it turns out that we have a sort of definition for this, right? A relation between two sets is called a collection of ordered pairs, right? And it turns out that this first set we call the domain, or we might hear it called the input. And then the second set is something we call the range or the output. Now, it turns out that each ordered pair in the relation, it has one object from the first set, or one object from the domain or the input, and an object from the second set, or an object from the range and the output. Now, I know that that's a lot of words. I don't know how many of us out there are visual learners. I know that I am. So I'm going to sort of draw a diagram that might help us keep these words in a more ordered way of thinking in our brains, okay? All right. So one of the ways that we actually look at things called relations is we draw something called a mapping diagram, all right? And it kind of looks like this. So we have like one blobby looking thing, right? This is our first set. Right? We also call this the domain. We also call this the input. And we might even hear this called as the independent variable, right? An independent variable. And then we also have a second set, another blobby looking thing. And this second set we call the range, right? So not the domain, but the range, not the input, but the output, and not the independent variable, but the dependent variable, okay? And in order to have a relation, we grab one element from here and one element from here, and we put them together in an ordered pair, okay? So let's take a look at some more examples. All right, first example up here. Example 1, all right? We've got a blobby looking thing. This is our first set, our domain, our input, our independent variable. And then this is our second set, or our range, or output, or dependent variable, okay? So let's take a look at the questions here. What is the domain of this relation? Well, as it turns out, the domain is just going to be the things in the first blob, right? And the way that we write it looks something like this. We're going to have in squiggly brackets, we'll list all the elements here. So we have A, B, C, and D. And so I'm going to go ahead and write those over here. A, comma, B, comma, C, comma, D. Oops. All right, close off the squiggly brackets, and this is my domain. All right, well, how do we find the range? The range is going to be something similar, except we're looking at the second set, or the output, or the dependent variable. And here we have a 1, 2, 3, and 4. And so inside some squiggly braces, we're going to write Roman numeral 1, Roman numeral 2, Roman numeral 3, and Roman numeral 4. Right, so we've got our domain and our range. Now, what is the relation? Well, we have to write the ordered pairs. And we're going to list these ordered pairs inside of some curly braces, right? Let's see what the pairs are looking at the diagram first. So the first pair I see is that A goes to 1. That means that A, comma 1 is an ordered pair, right? That means that B, comma 2 is another ordered pair. C, comma 3 is another ordered pair, and D, comma 4 is another ordered pair. And so making sure I leave myself enough room here, in a squiggly brace, I've got parentheses, A, comma 1, B, comma 2, C, comma 3, and D, comma 4. Ooh, perfect spacing. Close it off, and that is the set of ordered pairs in my relation. All right, let me zoom back out so we can take a look at all of example 1, but we've got our domain, our range, and then the relation. All right, now if you feel like you have the hang of this, this might be a good time to pause the video and go ahead and try number 2 on your own. All right, so I'll give you a moment to do that if you like. Otherwise, we're going to continue on and take a look at this example together. All right, so let's look at this mapping diagram. We've got an input, or our domain, or the output, our range. And this time we've got some regular numbers, 1, 2, 3, 4 in the input, and we've got lowercase letters in the output or the range, A, B, C, D. All right, so what is the domain of this one? I'm going to go ahead and say squiggly brackets, 1, comma 2, comma 3, comma 4, close it off. My range is going to be the things or the objects in the second set, so A, B, C, and D, A, comma B, comma C, comma D. And the relation is all of the ordered pairs that we see. All right, so let's use our diagram to look over the ordered pairs before we write them down. So we've got 1, comma A, but we also have 1, comma B, right? We've got 4, comma C, and we've got 2, comma D, right? So let's write those out. Open a bracket, we've got parentheses 1, comma A, 1, comma B. What came next? 2, comma D, and then 4, comma C. 2, comma D, and 4, comma C. Close that off. All right, so we've done our second example here. All right, just looking at the mapping to find our domain and our range from the first and the second set. All right, and let's take a look at our third example. We'll try this one more time. Again, if you'd like to try this on your own, you can pause the video here, and then I'll go ahead and explain that. You can come back and watch that explanation once you're done. All right, for those of you who want to go through this one together, all right, we've got our input and our output, just like we had in the previous 2 examples. And we are asked the same questions. What is the domain? What is the range? What is the relation? Okay. So domain in this case is going to be 2, 4, and 3. And usually we write those in order from smallest to biggest. So in my domain over here, I'm going to write 2, comma 3, comma 4. Right? For my range, I notice I have 3 values in the second set, 20, 30, and 40. So I'm going to go ahead and write in my squiggly brackets 20, 30, and 40. Last but not least, let's go ahead and find the relation. That means that we need to find all of the ordered pairs from our mapping diagram, right? So let's go through our ordered pairs together. We have 2, comma 20. we've got 2 comma 40. We've got 4 comma 40, and we've got 3 comma 30. All right, so let's write these out over here. We said 2 comma 20, but also 2 comma 40. And then 3 comma 30 and 4 comma 40. So 3 comma 30 and 4 comma 40. All right. So I hope we're getting the hang of identifying the domain and the range and the relation here as it comes with our mapping diagram. All right, so now I want to go back over the 3 examples that we've just done. All right, so we've taken a look at the domain, the range, and the relation. But if we scroll back up to this question or this topic, what we really want to see is a relation and a function. All right, so it would be important for us to be able to answer this question, what is a function? All right. Now it turns out that example 1 here is an example of a function. All right, so this one is a function. All right, and it turns out that example 2 is not a function. All right, so let's take a look at just these 2 on the page right now and see if we can identify some factors that make example 1 a function, but example 2 not a function. Okay, so some of us might think, well, example 1's a function because all of the arrows go straight across. That would be a guess, right? And over in the second one, we have arrows that sort of crisscross. It turns out that's not actually the reason. What makes example 1 a function is that every input value only goes to one output value. Right? Let me say that again. Every input value, so for example, C only goes to 3. And if we look down in example 2, right, 4 goes to C, that's fine. But where does this break down? 1, when I put in 1, I either get A or I get B. I have 2 values that come out when I put 1 in, okay? Let me highlight that. Let's pick a good color here. Ooh, I hope we can see this. But this piece right here, okay, the 1 going to A and B, that's what makes this relation not a function, okay? Well, let's take a look at example 3 then. What do we think about example 3? Let's see. 3 goes to 30, that's fine. 4 goes to 40. But 2 is a little bit of a problem child right now, right? 2 goes to 20, but it also goes to 40, okay? 2, the input gets 2 possible outputs, so this is not a function. Right? Not a function. Now, one of my favorite questions to ask myself as a mathematician, but also you folks as other mathematicians, is what could we do to make it a function, right? What if we change this? How does that change the problem? And so one of the things I'd like us to think about here is how can we change this mapping diagram so that we get a function? I'll let you think about that for a moment. Right? Now, one thing that we could do, if we made 2 not go to 20, it only went to 40. all right? 2 only goes to 40 now. That would be fine. This would make example 3 a function, okay? Simple change, but that's the difference between a relation and a function. A relation is like we put a bunch of numbers or letters in here or whatever we have, and we draw some arrows and we're fine, right? But in order to be a function, every input can only go to one output, okay? All right, so another important thing for us to talk about is this idea of notation, all right? Being able to write mathematically is a really important skill. So let's start with what might be familiar, right? Something that might be familiar to us is this equation y equals mx plus b, right? Now, I bet if we were all in class together and I asked you to tell me about y equals mx plus b, we would say that it's a line. We might even know that b is the y-intercept, m is the slope. Maybe we could tell us other things about that line as well, okay? But what's important for us right now is that this is typically how we see a function written, right? But in the language that we're just using, let's get some colors going here. X is our first set or our domain or our input or our independent variable. All right, that's our first set, our domain, our input, our independent variable. But on the flip side, y, this is our second set, our range, our output, or our dependent variable. All right. And if we think about this in a mapping diagram, we might have something like this. Something in a red blob and something in a green blob. And whatever the elements in there are, they map to different things in the second set. And we would say that an ordered pair, x comma y, would be something that is a point on the line, okay? Now, the y part is probably very familiar to us. But if we look at what might be new, all right, I still have mx plus b, but I've now changed the y to be an f of x, right? It means the same thing. In fact, I'm going to use that same color. F of x is how we call the second set, the range, the output, the dependent variable, okay? And if I were to write in some words, a few things that we might want to say about this is that we would read this as f of x. And we would not read this as, so not f times x. Okay, so we don't want to say fx or f times x. It is f of x, right? So f of x. And what this means, oops, not in the red color, because this is what it means. F of x means you plug x into the function mx plus b, right? And then we get a value out, and that is our f of x, okay? So if we were to relabel these blobs here, we could say that we have our all of our X values, and they're all going to f of X values. And so our ordered pair would now be X comma f of X. Right? So over here, we would have X comma Y, but over here, we would have X comma f of X. And that's just the notation that we use. We're going to be using it quite a bit. We might use X and Y. We might use A and B. We might use f of X or G of X or N of X, whatever letter, it doesn't actually matter. What we're describing is that we're going to plug something into a function. We're going to get a value out. All right. So let's take a look at a quick problem here. All right, example 4 says a function d equals f of X gives the number of donut shops in Los Angeles in a given year X. What does f of 2023 equals 1,500 mean? And what does it not mean? Okay. So I'll let you think about that for a little bit. When you're ready, continue on in this video. But this right here means in the year 2023, there are 1,500 donut shops in Los Angeles. All right, so my input is the year, so 2023, and the output is the number of donut shops. Okay, so in 2023, there are 1,500 donut shops in LA. Now, what does it not mean? Right? What does it not mean? I'll give you some time to think about some things that it might not mean. But here's one thing. In the year 1500, there are 2,023 donut shops in LA. Okay, so one mistake might be that we switch our input and our output. We're not reading our units carefully and we misinterpret what that means. All right, so it would be important that we keep the order there. But I bet you all are pretty creative. Spend some time and think about what other things could it not mean? How could someone misinterpret what this means? Okay. All right.